So I'll start the next topic, which is refraction of light through a prism. So what is a prism? Prism is a transparent medium. Transparent medium we can see through it. Okay, bounded by five plane surfaces. Okay, bounded by five plane surfaces with a triangular cross section. Let me show you the figure and explain it to you. See that this is a prism which is bounded by five plane surfaces. One triangular surfaces, the next triangular surfaces, and two, one, two triangular surfaces, and three rectangular surfaces. One, two, and base three. So it is bounded by five plane surfaces. Out of these, two surfaces are triangular and three surfaces are rectangular. Okay, and therefore this prism has triangular cross section. Got it? So you can see these two surfaces in the figure. These two surfaces are called the refracting surface because here the light comes and gets refracted, and this AD, which is connecting these two refracting surfaces, this edge we call it refracting edge. AD is the refracting edge. And one thing you can see over here is that these two refracting rectangular surfaces are not parallel to each other. They are not in the same direction. Okay, they're inclined to each other like this, and the angle between these two rectangular surfaces we call it angle of prism. These two rectangular surfaces or refracting surfaces, the angle between them we call it angle of prism. So this is the structure of prism. Okay, uh, the two refracting surfaces of prism are not parallel to each other, as I told you, but they are inclined on each other, making an angle A. They are inclined each other. Number two, in a ray diagram, a prism is shown only by its principal section ABC. So whenever we show the ray diagram, we only have to show this ABC, the cross section ABC, which we call principal section. So here we explain how the light rays get bent or emerge out of prism with the help of ray diagram. So for that we have chosen only the principal section ABC of a prism, which is triangular. Okay, so ABC, this angle between them we call it angle of prism, that we know. This angle BAC, this angle is the angle of prism. All right, so here the incident ray, you can see the incident ray is a light, a monochromatic light, means a light of single frequency or a light of single color. Okay, we have a monochromatic light which is incident on this prism, and AB is the surface on which this light is incident. And see the dotted line over here, this dotted line which is PN, this dotted line is normal to this surface. Similarly, AC is another surface of the prism, and this dotted line which is QN is the normal to this surface. So we need normal, no, so that we find the angle of incidence. So this incident ray striking this surface at point P, and the angle between this incident ray and the normal we call it angle of incidence. Alright, so this original direction of the incident ray is shown by this dotted line. Since this is rare medium air and this is glass denser medium, the light bends towards the normal. So this is normal, so light ray bends towards the normal, and instead of going towards PM, the light goes towards PQ. Okay, it goes towards PQ. Again, it strikes the second surface at point Q. So this is the normal of the second surface. So again, it is moving from denser to the rare medium. Therefore, it will bend away from the normal. It will bend away from the normal. As a result, the emergent ray would look like this. And the angle between this normal and this emergent ray, we call it I2. Okay, this is the angle of emergence. As I was explaining, the refraction of light through the prism. So this I1 is the angle of incidence with the incident ray made with the normal, and this is a refracted ray which makes an angle R1, which is angle of refraction with the normal, and this refracted ray strikes at point Q, and this angle made by this refracted ray with this normal, we call it R2, and this I2, which is the angle made by the emergent ray with the normal, we call it angle of emergence. Okay, so one thing that you have to understand over here is that, see, here the refraction takes place at two different surfaces. Okay, incident ray, refracted ray. Again, there is a refraction over here, and this is emergent ray. Okay, so one you can see that this is the original direction of incident ray. It suffers refraction at this point, and instead of going towards PM, it moves towards PQ, and this delta 1 is the angle of deviation. And this refracted ray at point Q suffers refraction further, since it is moving from denser to the rarer medium. Therefore, it bends away from the normal, and this QR is the emergent ray. And this QR appears to come from M. Therefore, this MQ makes an angle delta 2 with this refracted ray. Understood? So that's what they have said it over here in this line. See, thus in a prism, a ray of light suffers refraction at two inclined faces AB and AC of the prism. And each refraction, the ray bent towards the base of the prism. At the first face AB of the prism, the ray OP, instead of going along OPM, the ray OP, instead of going OPM, it moves towards PQ. And this PQ, after suffering refraction from this point Q, it moves towards QR. Okay, because of that reason, in the absence of the prism, the incident ray OP would have traveled along OPML. In the absence of prism, it would have traveled along OPML. Okay, and the emergent ray QR appears to be coming along MQR. This emergent ray QR appears to come along from here, from M. This emergent ray appears to come from MQR. Therefore, the total deviation, thus the prism has produced a deviation by LMQ. Since it suffers deviation delta 1, delta 2, therefore the total deviation it suffers is LMQ, which is delta. Okay, so this is the deviation delta, which we call it angle of deviation. So which is the angle between the direction of the incident ray and emergent ray. So this delta, obviously this is the direction of the incident ray, and this is the direction of the emergent ray. So this angle delta, which is called angle of deviation, is the angle between the incident ray and the emergent ray, angle between the direction of the incident ray and the direction of the emergent ray. So which we can write as this. So therefore this LMQ delta equals to sum of delta 1 plus delta 2. Okay, angle of deviation is sum of this delta is sum of delta 1 plus delta 2, which is true also, because if you consider this exterior angle is sum of the opposite angles delta 1 and delta 2, which is here. This is equation 1. Now let's solve some mathematics over here. This I1 and I2, which is MPN, obviously, and QN is I1 and I2 from the graph, and this MPQ. See, this MPQ is delta 1, alright? This MPQ, you can see these twos are opposite angles, alright? This I1 and sum of delta 1 plus R1 should be equal, because these angles are opposite angles, therefore they have to be equal. So delta 1 plus R1 should be equal to I1. From there I can write delta 1 equals to I1 minus R1. Understood? Delta 1 plus R1 should be equal to I1, because these are opposite angles. Therefore from there I can write delta 1 equals to I1 minus R1. This one, understood? Similarly, see, this angle and these angles are opposite angles, which has to be equal. So I2 should be equal to delta 2 plus R2. From there I can write delta 2 equals to I2 minus R2. Understood? So from this equation 1, which is delta equals to delta 1 plus delta 2, I can write delta equals to, in place of delta 1, delta 2, I just write this one, and I just arrange it, and I got 4.9 equation. That this 4.9 equation I'll use it later, but I got this equation. Alright, now let's see this APN. See this APN. Since this PN is normal to this face, therefore this APN is 90 degree. And also this AQN, this is also 90 degree. Alright, so this APN and AQN is 90 degree. And sum of these two angle, APN plus AQN, has to be 180. Now if you see this quadrilateral APNQ, this is a quadrilateral. This quadrilateral, what is the property of this quadrilateral? This sum of this all angle has to be 360, no? Sum of this whole angle has to be 360. That's the property of this quadrilateral. And we know this APN and this AQN is 90, which is 180. Now rest of this angle and this angle has to be 180. Sum of these two angle has to be 180. Alright, I'm repeating again. The sum of this quadrilateral, this angle, this angle, this angle, this angle, if you add up, it has to be 360. But for we got it that this APN and this AQN are 90 degree. Therefore, sum of these two angle is 180. Now the sum of this rest, this angle has to be 180. That's what they have written over here. See, this is very important. This PNQ and PAQ. That means this PNQ and this PAQ has to be 180. From there, it has come. It has to be 180. And PAQ is this angle. This PAQ is angle of prism. So we can write, instead of PAQ, we can write angle A. Okay. And PNQ is, from this equation, 180 minus A. Okay. 180 minus A. This is equation 2. And this is one equation 2. Now again in triangle PNQ, if you see this triangle PNQ, then what is seen over here is this triangle, sum of the angles in this triangle, R1 plus R2 plus this angle should be equal to 180. That's the rule. That's the property of this any triangle. Sum of the all three angles has to be 180. Here R1 plus R2, we don't know this PNQ, but we can write PNQ equals to 180 minus R1 plus R2 we can write. So therefore we got PNQ equals to 180 minus R1 plus R2. Now equation 2 and 3, if you see this, both are PNQ, therefore both has to be equal. So we just equate this one. This equate this equal to this, which will give you A equals to R1 plus R2. Now this A, R1 plus R2, we use in equation 4.9. If you see the 4.9 here, then we can replace this R1 plus R2 by A over here. And finally we get this relation, R1 plus I2 equals to A plus delta. Understood? This I1 is the angle of incidence, I2 is the angle of emergence, A is the angle of prism, and delta is the angle of deviation. This is the final relation we got.